So this recording is for my 440 students trying to work on the project to get the code running for the single cycle MIPS processor. Uh, what I wanted to do is just take a little bit to show you a few of the tricks that you can play with the Xilinx software that can be quite a bit of help in debugging these types of problems. So specifically what I'm referring to is in our test bench, taking advantage of the Xilinx capability. Now we've learned about dollar display, which allows us when we run our program to output to the console certain messages. What we haven't talked about yet is that you can also create a file that allows you to write your dollar displays, your dollar writes to. And in the end, what it gives you is a beautiful database that you can go in and then search to follow where your program ran. So the syntax is first you need to define an integer. I declare the integer file because I have no imagination. Then you can open the file by doing a file open, $file open with your file name, and it'll go into the default directory where you invoke the simulator. And it'll associate it with the name file. This could be Bob, Sue, you choose. Once you've opened the file, that allows you then to output to it. So what I chose to do, because the execution of our code on every clock, we should change PC. And I realized that if I traced my PC, I could see exactly where I was moving through my code. So I chose the off clock just because it's away from any of the transitions. So always at the negative edge of the clock. What I would do is I'd do a $F write, and I would display the current value of the PC. So what I'm doing is I'm allowing myself to follow how my code is being executed line by line. That's why it was important to have, okay, so I know what's going on. I've got my other screen connected. So what I want to show you is my sample code that I put together for writing my code and then generating the machine code. So here is my assembler help file, and it looks just like the one I gave you, except I've went in and I've done a few things. I've put some comments in. Like I said, you should break up your program into functions. So I did my sorting first, then I did my adding of my sorted values, then I did the summation and the anding of all my different values. Now, since I have my PC here, what I can do is I can then, by following the execution that I'm printing, I can see exactly how my code is being executed. And that is a tremendous asset. Particularly you get into some iterative loops. So let me pick an address that has, so 40 has an iterative loop. So if I look for 00000040, what I'm going to find is I'm continuously iterating through that location. And what I can do, I can then go through and count how many occurrences there are to make sure that I'm doing my loops exactly the way I think I should. While I'm here, let me mention again, we have our code, which is our instruction memory. And how I was able to create that was, let's say I want to select all here, and I will get rid of it real quickly. Make sure I'm in insert mode, and I come back and I do a click and drag, select, and then I do a paste. Come back, grab my next block of code, copy, paste, come into my last block of code, do a copy, and paste. So now I've got my instructions. Now notice that there's a tab in there. This is why I like using VI. So I say from the first line to the last, search for a tab and replace it with nothing. And so now what I've got, I have my instructions lifted directly from my spreadsheet that I can then use when I want to run my program. So this, I also came in and added comments so I could know exactly what I was doing. So let me get back to where I was at. Let me save that. I'm sure it's okay. Let me open my keep it again. Yeah, it'll take a while. So this is quite a beneficial practice. So doing the F right, the F right is similar to an F display except it doesn't append a carriage return line feed at the end. So then I said, okay, in this case I wanted to see every time I wrote a register. So I said, okay, if my reg write is active, then I'm going to display the write address and the data that I'm writing. Now, by showing you this, it gives you a feel that you could do a lot of things, whatever you want to look for in your design. Now, because I know my code, and I know that my last instruction is E0, what I did was then I went and looked for my PC to equal E0. That told me I was done. Then I went in and I displayed the values that I had stored so that I could then check and see what my results were. So let me say that looking at the waveforms to try and check out an iterative program like this becomes somewhat confusing, although it's excellent to get that first feel and to be able to get a general feel of what's going on. Specifically to be able to go in and look at exactly how your code is running. You can choose exactly what values you want to display. It becomes much easier to debug your code. So I hope that everybody's doing all right. I hope you're working on it. This is not a project that you will be able to complete in a cram session the day before it's due. It's something you need to get into and revisit several times in order for you to get it going. We've got a handful of different things working together. So basically, looking at my code, that was about it. And so my test bench is exactly what I had before. I read my instruction in, I read my table in that I've distributed to everybody, open my file to help me debug, turn on my clock and turn off my reset, and away we go. And without a doubt, it takes a little while to run, but creating this file, like I said, really helped. Now, on a side note, just for those of you that are interested, what I did was I downloaded, let me close these guys. So I downloaded the Python for Windows 7. And it's a nice little environment. that allows you to set up your code. Now, what I did with this code was I wanted to replicate the behavior of my MIPS single cycle processor. So I read in my data memory. I have the output, but I didn't write to it. And in essence, what I did in the Python was I go ahead and read in all the values from the file. I'm doing some conversion to get signed and unsigned values. Then I go ahead and sort all of those values. And then in the end, I generate my sums and I output to the screen what my values are. And right now, my checksum's the same. I think my bottom sum's the same. My top sum isn't quite the same. I got to figure out exactly what's going on there. But I'm in the ballpark. So uh, Python is pretty easy. The nice thing is you can just run. It'll open up the window. It go ahead and runs. If you have errors, which you can see, aha, so I have some history that I had some errors previously, and then I get my results. So I hope this little video helps us to be able to get into this. Nobody's been pinging me, so I hope you're working on it. And if you have questions, again, feel free to send me email. And I look forward to seeing you guys all next week.